have the graph of 2x plus 3y equals 12. As previously explained, what this line represents are all of the possible solutions to this equation. Specifically here, I've listed three solutions: x equals 0, y equals 4, x equals 3, y equals 2, and x equals 6, and y equals 0. Here we're going to look more closely at ways of graphing linear equations, but we first need to identify the really important components of this equation. First and foremost, we have this point right here of 0, 4. We call this the y-intercept. We call it the y-intercept because it's where this line will cross the y-axis. By the way, per definition, the y-intercept will always have a 0 for the x value right here, because that's what puts this solution on the y-axis. Our x-intercept is very similar to the point where our line crosses the x-axis. In this case, our x-intercept is 6, 0. Our x-intercept will always have a y value of 0 for exactly the same reason the y-intercept has an x value of 0. Again, quickly to summarize, the y-intercept will always be the solution when I plug in a 0 for x. In fact, a way of finding the y-intercept is always just to plug in 0 for x and solve this equation for y. In the same way, the x-intercept is always the solution where y was equal to 0. We could find that by plugging in 0 in for y and solving the equation for x. Now the slope. The slope is one of the most important parts of this equation. Slope describes the rise and fall of this line. In fact, we're going to break linear equations in two variables down to two important components. The y-intercept will give us some idea about this location of the line, and the slope will tell us the rise and fall of the line. If we have those two bits of information, we can quickly graph any line. The slope is defined by being the rise over the run of this line, or how far you go up or down compared to how far you go left or right. Mathematically, we describe this as the change in y over the change in x, and I will describe these both in the same way on this line right here. Importantly though, for future use, if you have 2 points and are ever trying to find the slope without a visual, you can use this expression right here, y2 minus y1 over x2 minus x1. To identify the slope, we take any 2 points for our equation, and we identify the rise and the run between the points. In this case right here, I will look at the slope between the solutions of 3, 2 and 6, 0. To find the rise, I will just go vertically straight down as far as I need to meet this point. So I will go down here. In this case, I'm going down 2. I use a -2 to denote going down versus a +2 would be going up. Horizontally, I'm going over from x equals 3 to x equals 6. And this would be a run of 3. So the slope for this equation is -2 for the rise over 3 for the run, specifically. Now it's time to show you something pretty awesome. If I take this linear equation in 2 variables and I solve that equation for y, I will always get this beautiful fact. The coefficient in front of my x value will always be the slope for my line, and the constant being added here afterwards will always be the y value of my y-intercept. In fact, if you understand y-intercepts and how slope works, all you need to do is simply solve a linear equation for y, identify the coefficient in front of your x for your slope, and identify the constant coefficient for your y-intercept, and you can simply graph this line with that information. If I take a linear equation in 2 variables and I solve it for y, in this case I would subtract 3x from both sides to get rid of this 3x here. I'm left with -4y equals really 24 minus 3x, but the nice way to write this is minus 3x plus 24. I always like having the term with the x first on this side of the equation. And then I would divide everything by -4 to get y equals This will be 3/4 x minus 6. I have a y-intercept of -6. That's my first point. In this case, it would be right here. Then I have slope. This slope right here is the rise over the run. And that rise over the run is 3/4. Again, what this is telling me, this is the steepness of this line. This is also telling me how to get from this point to a second point and a third point. So I start at 0, -6. I'm going to go up 3 units and to the right 4 units to find my next point. 1, 2, 3. 1, 2, 3, 4. This is my next point right here. This, again, was 0, -6. This point is 4, -3. Finally, just to show for one more solution to this equation, or one more point, I can go up 1, 2, 3, and then over 1, 2, 3, 4 to find my third point. If I then draw the line connecting these points, I have a graph of this linear equation.